And I'm 8 years old, and I'm going to be teaching you about flat Earth. So first we're going to start off with gravity. Gravity is a theory, not a fact. Mass attracting mass never been proven properly. This happened in 1666. An apple fell on Isaac Newton's head. It must have been a big apple for him to believe in gravity. Gravity is fake because density and EMF are making things drop, not gravity. There is iodine salt in this cup and no iodine salt in the other cup. There is 2 cups of water with an egg. One with iodine salt, with no iodine salt. This one has iodine salt and it has electricity because electricity is pushing the egg up. On the other one, it has no electricity in it because the egg is denser than the water. Density and surrounding medium with EMF. That stands for electromagnetic frequency. If gravity can't be proven and Earth is 70% water, we know water stays level, then 70% of Earth is level. Now we are going to move on to the globe and our flat Earth. So say there's a boat just cruising on the bottom of the Earth. It would fall into space, and space is fake. If space was real, stars would have parallax, but they don't. So it would just fall into space. And this is for anything that can't go upside down. If people believe that the Earth is round, people don't walk upside down. Same with a boat. It doesn't sail upside down. They think this is true on that. Well, no. It is not. This is our true flat Earth. And the thing around it is the firmament. I'm going to tell you how the firmament is real. The firmament is real because air pressure has to be contained, just like in a tire. Now we are going to move on to seasons and the sun. The spinning ball globe believers say that the sun is 93 million miles away. The globe depends on parallel rays for the seasons. All you have to do is use your God-given eyes to see we have crepuscular rays from the sun. Crepuscular rays proves we have a local sun. That proves everything about seasons and the sun. Now we are going to move on to a sun, moon, and earth depiction. The sun is shining on the moon and the moon is shining on the earth. Why is it not shining its temperature on earth? Well, me and my dad did an experiment one night on a full moon, and we used a laser thermometer to check the moon's light and its shadow. The moon's light was colder than its shadow, so that proves the light is colder than its shadow, and proves that the moon has its own light. The sun is not reflecting its light on the moon. The moon has its own light. Thank you for watching my flat earth presentation. I hope you guys liked it. And Jesus Christ is the way, the truth, and the life. Just remember, the truth does not fear investigation. Thank you for watching. Bye.
If the Earth were a globe with a curvature drop roughly equal to 8 inches per mile squared, and the surface of the Earth and its atmosphere allegedly rotated at approximately 1,000 miles per hour at the equator, as claimed by the globe model, you'd assume those claims would be vital to NASA and the military for modeling and building aircraft. Instead, you'll see through declassified documents that government agencies and their contractors repeatedly assumed a flat and stationary Earth. For example, this NASA document assumes a flat, non-rotating Earth. Georgia Institute of Technology, on behalf of NASA, the model used is a flat, non-rotating Earth. Technical memo from the NASA Langley Research Center, flat, non-rotating Earth. NASA Technical Memorandum, flat, non-rotating Earth. NASA publication on the derivation and definition of a linear aircraft model, flat, non-rotating Earth, and flat, non-rotating Earth. NASA contractor, flat, non-rotating Earth, and flat Earth assumptions. NASA Ames Research Center, non-rotating flat Earth. Army Research Laboratory, flat Earth. Army Research Laboratory, propagation of electromagnetic fields over a flat Earth. Army Research Laboratory, a flat Earth approximation provides the best estimate. NASA Technical Paper, stationary atmosphere over a flat, non-rotating Earth. NASA Technical Memo, a non-rotating Earth. MIT Department of Aeronautics and Astronautics, flat Earth, flat Earth. NASA Memo, flat, non-rotating Earth. NASA Contractor Report, assumption based on the Earth is flat and non-rotating. NASA Technical Memo, flat, non-rotating Earth. NASA Technical Paper, stationary atmosphere and flat, non-rotating Earth assumptions. NASA Technical Note, flat, non-rotating Earth. NASA Langley Research Center, flat, non-rotating Earth. Army Research Laboratory, these equations assume a flat Earth. Even the Soviets made their assumptions based on a flat Earth. If the Earth were a ball and rotated at 1,000 miles per hour, you obviously would not see the repeated engineering assumptions that the Earth is flat and stationary.
In the meantime, they are images that inspire, educate, and sometimes just make us say, wow. Yeah. Over the years, NASA has given us spectacular photos and renderings that reveal a colorful and mysterious universe.
No doubt. And now Chris Martinez is introducing us to two of the artists behind some of the most iconic space art in the galaxy.
In a small, bright office, working side by side,
let's see,
Robert Hurt and Tim Pyle bring the universe to life.
What we're doing does have real science underlying it.
Robert is an astrophysicist turned artist. Tim, once a Hollywood animator, is now a planet illustrator. Together, they produce some of NASA's most popular images, from renderings of how planets light years away could look, to actual photos of stars and galaxies captured by NASA's powerful telescopes.
And this is sort of how it comes to me.
Many of those images have a dark, grainy start, but color and light reveal an astonishing glimpse of how the deepest regions of space might appear to the human eye.
What I'm trying to do is show people sort of the broader colors that the universe has to offer.
It's a delicate blend of imagination and data. The artists meet with NASA scientists over many drafts to ensure a planet or galaxy's look lines up with the research to make each one as accurate as possible.
I love the challenge. It's kind of like a puzzle to me of trying to create something that looks really cool within the restrictions that were given by the scientists.
It can take days, even weeks, to produce just a single image. The dazzling final results, enough to keep us all dreaming of the final frontier for years to come. Chris Martinez, CBS News, Pasadena, California.
The artists also say they have to be especially careful when it comes to illustrations of other planets to avoid colors many of us would associate with Earth, like blue for water.
What is gravity?
You have no idea. Okay, next question.
Wow.
No, here's the difference. We can describe gravity. We can say what it does to other things. We can measure it, predict with it. But when you start asking, like, what it is, I don't know.
The shot is compiled from data from NASA's VEERS instrument, which orbits the Earth about every 100 minutes, taking measurements of light coming off the planet. That can be translated into ribbons of imagery like this, and then into one of these. And this is just the latest in NASA's Earth from Space album, which may be one of the most mind-expanding collections of images in human history.
Heart nebulas, celestial collisions, a bird's eye view of the Milky Way, astronomers are charting the outer reaches of the cosmos and bringing back jaw-dropping images from telescopes like Hubble and its infrared cousin Spitzer. If you look down at the bottom of that Milky Way image, you'll see these two words: artist concept. This sweeping image of the Orion Nebula actually looks like this. And the TRAPPIST-1 star system, the latest discovery of 7 potentially habitable exoplanets that made national headlines, it's really only a box of gray and white pixels. You see, space art is part of NASA's most fascinating images. Most space imagery begins with data. Very, very complex data. And transforming these numbers and graphs into an image that captures the public's imagination requires a delicate balance between science and art. And that is where Robert comes in. As an astronomer and artist, Robert isn't editing images so much as he's making an artistic hypothesis grounded in facts, so we can visualize what's really happening up there.
It's primarily taking data and making pictures out of it.
That's what this is, a composite of data sets from several different instruments translated into a picture.
To us, the really cool thing was the data set. Up until that point, there was no realistic color map of the globe anywhere.
So the land layer here comes from
The moderate resolution imaging spectroradiometer aboard Terra.
And the tricky part here was the weather.
So we actually had to take clouds out.
They stashed the clouds for later, went onto the ocean. That came from an instrument that measures phytoplankton in the sea.
Where it was low, I colored it dark blue because they're low mostly in mid-oceans. And then where it was a little bit higher, it was like a little bit brighter green.
Then add the clouds back in.
There's a small problem with it because there's a very slight gap in between each orbit.
So some of those are painted on.
It is photoshopped, but it's has to be.
Then
there was another layer to sort of simulate the atmosphere.
And then there's this little bright spot.
It's called the specular highlight. So it's the reflection of sunlight off of water.
Those are the pieces, but you can't just slap them all together.
It just didn't look realistic. It looks kind of flat, or the clouds are sort of too see-through. So I just hit Command-Z a lot.
There's artistry to creating the world.
What I imagine it to be. Unfortunately, I'm not an astronaut. I've never been to space. But I've looked at these images over and over again.
Robert takes the scientific limitations seriously because the wrong color could be very misleading.
Rendering an exoplanet with bright green continents would be kind of crossing a line for us. We don't want to say, hey, we found life on this planet, and showing green really would communicate that. It's enough to show some evidence of water. In fact, a lot of times we've made special efforts to make the water not look super appealing, not like this tropical deep blue appearance, because you would think that complete accuracy would be the goal when you're doing astronomical illustrations, but it isn't always the case. The primary goal is communication and understanding.
Having a visual response to technical triumphs was something NASA latched onto early on. For over 50 years, NASA worked closely with artists and creative leaders like Walt Disney and Norman Rockwell to help shape the stories of spaceflight. It's the same legacy today, just with more advanced scientific understanding and better tools to imagine what far-off worlds might look like if we could visit them.
We want to take a lot of care to make sure we don't oversell the part of the story that isn't actually the story. There are people who just look and think, oh, NASA's photographed a planet, and they don't understand that actually that was a piece of art. On the other hand, if we don't do that and we don't put a piece of compelling artwork, then people may never even look at the story anyway.
I'd go to the moon in a nanosecond. The problem is we don't have the technology to do that anymore. We used to, but we destroyed that technology, and it's a painful process to build it back again. But going to Mars should be one of the next series of steps that humans do. The first step should be going back to the moon for a number of technical reasons and exploration reasons, and then after that, Mars, maybe high orbit in Venus atmosphere, maybe going to Europa. There's all kinds of targets to go to, places of interest in our solar system. The only limit to human future is in our own imagination.
I haven't seen anything that indicates the telemetry data is even in existence, and as I said, even if we had it, we don't have the machines to play it back.
But your own research has shown the telemetry data is missing.
That's right.
The film you're making now, what is it? Does it have a name? I mean, do you have a name for it yet, or
I'm calling it Did We Go?
Did We Go? Okay.
Doesn't have it either. The Smithsonian doesn't have it. Johnson doesn't have it.
Right. We've been unable to track it down. I mean, we don't know where this telemetry data ended up, and we don't know what path it may have taken. So, unfortunately, I'm afraid I can't really give you much of a clue as to where this data ended up.
Whilst in space, have you ever looked away from Earth into the black void?
Yeah.
Because
you can see. Because you can see the stars.
Oh yeah.
And pretty much all the time you can see the stars.
Yeah. It's not a black void. I mean, it's black, but there's all kinds of little polka dots.
There's all the stars there, and the cool thing is about it, you can see it during the day.
Yeah, you can, and there's more than stars. You can see planets. You can see moons.
You see the gas. Magellan clouds of the Milky Way
you see
galaxy.
The Magellanic clouds.
Magellanic. See, I just wanted the Magellan clouds.
There's a large one
I didn't
and a small one, right?
Yeah.
And then you can see the zodiacal lights.
Whoa.
Those are amazing. Right before
the lights
sunrise.
of the zodiac.
The lights of the zodiac, the zodiacal lights.
But one thing to add to this, I think, which is kind of interesting about being able to look into the black void, is that we can't do that when the sun is out here on Earth, and it's not because the sun is so bright. It's because this atmosphere.
Yeah.
Right? The light comes through the atmosphere and refracts, and we
scatters.
see blue. It scatters.
Yeah,
we see
it
blue.
scatters.
So what we see is.
When you looked up at the sky, could you actually see the stars and the solar corona in spite of the glare?
We were never able to see stars from the lunar surface or on the daylight side of the moon by eye without looking through the optics. I don't recall during the period of time that we were photographing the solar corona what stars we could see.
I don't remember seeing any.
Neil, Mr. Armstrong, I do realize that when you were on the moon, you had very little time for gazing upwards. But could you tell us something about what the sky actually looks like from the moon, the sun, the earth, the stars, if any, and so on?
The sky is a deep black when viewed from the moon, as it is when viewed from cislunar space, the space between the Earth and the moon. The Earth is the only visible object other than the sun that can be seen, although there have been some reports of seeing planets. I myself did not see planets from the surface, but I suspect they might be visible.
You don't see stars in the daytime on Earth, not because they're not there, but because the atmosphere is aglow with scattered light from the sun. If you take away the atmosphere, the sun will still be there, but the sky goes dark. That's what the folks get when they go to the edge of the atmosphere, and they're calling that the edge of space. But when you get to the edge of the atmosphere is no longer between you and the rest of the universe, and the stars reveal themselves just as they would at night. Since the moon has no atmosphere, then a daytime picture, if you're there in the daytime of the moon, you see a full night sky of stars, even with the sun in the sky as well. But when you get to the edge of the atmosphere, the stars reveal themselves just as they would at night. If you're there in the daytime of the moon, you see a full night sky of stars, even with the sun in the sky as well.
The sky is a deep black when viewed from the moon, as it is when viewed from cislunar space, the space between the Earth and the moon.
So as you can see the stars.
Oh, yeah.
You know, and pretty much all the time you can see the stars.
Yeah. It's not a black void. I mean, it's black, but there's all kinds of little polka dots.
There's all the stars there. And the cool thing is about it, you can see it during the day.
Yeah, you know, actually on my very first mission, we went up and when you're in space and you're looking into deep space and you're on the sun side of the orbit, the sunlight washes out all the starlight, so you can't see any stars, just like here on Earth. But then when you look out into deep space away from the sun, it's the darkest black you can imagine.
So as you can see the stars.
Oh, yeah.
You know, and pretty much all the time you can see the stars. Yeah. The cool thing is about it, you can see it during the day.
And when you're in space and you're looking into deep space and you're on the sun side of the orbit, the sunlight washes out all the starlight, so you can't see any stars, just like here on Earth.
There's all the stars there, and the cool thing is about it, you can see it during the day.
They're brighter, but they're different. And a lot of things different about them. One, you don't have the atmospheric distortion, so they don't twinkle, right? So you see lots of points, and you see lots of points, and that literally millions of them. And I live in Colorado, and you get up on a clear night in Colorado up in the mountains where there's no light and you can see all these stars. Well, multiply that by 1,000. That's what it's like in space. And then when you're outside doing a spacewalk and you have that one or two opportunities where you can let your eyes adjust, you can start to notice that some of the stars have colors we don't see here on the ground.
And we could not see stars.
The sky, of course, was black, but it had sort of a velvet sheen to it.
The biggest visual surprise was just how black the sky was. You have a brilliant sun, brighter than any sun you normally would see, even here in New Mexico. You have these extraordinarily high mountains. We were in a valley deeper than the Grand Canyon. But then you have this black sky, a sky blacker than black, as the old Vidicon expression used to be.
Just the inherent beauty of it, the velvet, bottomless bucket of the universe.
In like just hanging there in a vast sea of darkness, and the most frightening darkness that you could ever imagine.
I've often tried to explain the difference between darkness, when you turn out the lights and it's dark in here, or blackness. Blackness is the endlessness of it all. It's hard to comprehend.
What was going through your mind? How amazed were you to see your roadster up there with Starman just cruising along with the blue planet? And how long will we be getting live views, do you think, from the car?
Well, I think it looks so ridiculous and impossible. And you can tell it's real because it looks so fake, honestly. Like, we'd have way better CGI if it was fake. And you know, the colors all look kind of weird in space. There's no atmospheric occlusion. You know, like everything looks too crisp. But we didn't really test any of those materials for, you know, is it space hardened or whatever, you know. So it just has the same seats that like a normal car has. It's just literally a normal car in space, which I kind of like the absurdity of that.
Why has nobody been to the moon in such a long time?
That's not an 8-year-old's question. That's my question. I want to know, but I think I know. Because we didn't go there, and that's the way it happened. And if it didn't happen, it's nice to know why it didn't happen. So
thank you very much again. Thank you for your time. Have a good flight and many more exciting experiments on the orbit. Thanks a lot.
Station, this is Houston ACR. That concludes the event.
And it's still tripping me out. I mean, I'm tripping balls here.